It started running into my mind. Okay, okay. I think we are live now. People in the chat, like if you can confirm one, if everything is working, then we will get started. What? Okay, my voice is like much.
Before we started streaming from your machine, your voice was not lagging. Video is it?
I mean, like what I see on YouTube studio page is like just take 1 hour for me. Okay, above we are live. Maybe you can turn on your screen and you can get. Hello, I'm very good by ICPC. It's a for the college starting for the episode and look like we will on the support. Looking at the scoreboard so far. Right long base and also the first on problem. Six wickets and like the second in terms for matters of beat and first I leave was by first I agree more fire and civil now as selecting problem base is for the decent project of and our character first you use from I so I tweet from the Zoom looking at a place about the using from units back has such problem as of the like within the maniacal is that few problems that on the spot from IIT where it's confirmed apart from Mumbai on the Vancouver and like I think this would like to introduce yourself.
Hi guys, I'm Above. And I do some live streams for the past few years. This is the last contest for move on to the finals. So there is no contest. It's not that we have from different specialist finds. And it's a big contest. We just comment out the Yeah, I'll hand it over to Aya.
Right. Yeah, and inform if audio have been the chat before continue further. I'm just the loading screen. Well, I can listen.
Hello.
Right.
How's it?
Now I'm trying to get inside and like looking about the hand of the
Mhm. Yeah, total bowling unsolvable in contest. Yeah,
but I don't really have problems or but not really probably the answer.
yeah, 6 perhaps. 7 is too optimistic.
Which ones do you think are unsolvable?
So, two of the problems are solvable, I mean, more or less unsolvable, exactly. So, one is this mode inverse quorum, and the C and D, essentially.
Yeah.
So, C is unsolvable in contest. D, we all, itself, less than 5% hours.
Okay.
But the video that you need is skills.
I have no idea. This problem had like, skill levels. I just,
Okay, like, generally like on post versus comment if you see someone has
yeah,
something like
yeah.
that.
So, but I'm there's also teenagers.
Okay, I mean I was aware of it.
Yeah, yeah. Are we still facing some issues?
Yes. Okay, hello everyone in the chat. Like, can we confirm if everything is running fine now before we get started? Like, we can keep our camera off for some time, and if everything looks fine, then we will turn on. Okay, hello everyone. Today we would be commentating on ICPC HRS contest 2023. The contest link is icpc.portals.io/contest. You will find the contest link and rank list there. And like right now, the status is like four distinct problems have been solved in the contest. Buri Buri Jaimon from IIT Roorkee is at the top, and then Yuruza Forever is at rank 2, and DU Ascending from University of Dhaka is at rank 3. These three teams have solved three distinct problems. And there are multiple teams at rank 2. Like the first AC from the contest was from team Lightlow on the problem Sitting Sweethearts. The second AC on the second distinct problem was solved by Buri Zoimon from IIT Roorkee Bob to the top team. And like the third distinct problem was solved by the same team Parker Rectangle. And the fourth okay, like basically the third distinct problem was solved by University of Dhaka and by DU ascending team, and the fourth racing problem was solved by Buri Zemon from IIT Roorkee again. And so we also have with us Vaibhav and Jatin. Like Vaibhav, would you like to introduce yourself first?
Hello everyone, I'm Vaibhav and we have been doing a few live streams for ICPC over the past few regionals. So yeah, welcome to the last contest of the season.
And we also have with us Jatin. Jatin, would you like to introduce yourself?
Hi, welcome everyone to the stream. I'm Jatan, and yeah, it's going fine. We don't spend a lot of results. It's been almost 90 minutes, and more or less only problems have been solved. The other problems have been solved by one team problems, but two teams have solved another problem. So yeah, so contest seems quite difficult, I guess. And yeah, the remaining problems are even more difficult. So Aryan, what do you think? How many problems are going to be solved today? Like, how many
Like,
problems, like, will the rank one team solve, and how many problems overall will get solved?
like overall, looking at the current status, like I think like the first rank team would be solving at most two more problems. Like that's my current assumption right now. Like because the thing is like teams try to follow the scoreboard and scoreboard is not helping here a lot.
Uh,
Uh,
right.
like for example, I see like weighted watermelon can be an easy DP problem, but I doubt people will try it out before they get AC on the four problems which are at least non-zero AC right now.
Yeah. Yeah.
And like modular square sum and Fendis 5, I don't expect AC here.
Hmm.
And like cabins in the wood might be something doable, like if some people try to spend some time on. And
Yeah.
like pretty much that's the problem status right now. And I would say like similar for skill issue as well. Like there we know like the number of states and like 2 pointer and optimizations are required. And looking at the current state, like I won't expect like teams would be able to even reach at that problem there. So like
Yes.
that's the current status. So like basically four distinct problems have been solved right now. And the next I expect like team to try out is weight test watermelon. That those would mostly be the teams at the top. And
Yeah.
after that, cabin in the wood might be they might have some sorted. And yeah, pretty much
Yeah.
that's
So I
the
think
status.
both Fatious Watermelon and Skill Issue are like math plus TP-ish problems, and both have like similar difficulty, more or less. So yeah, either of those two will probably be solved first. I think like uh, this cabin in the woods problem is more, I think, standardish, and but it has like a longish statement, so maybe it will not be. Yeah, I don't know. So one of the last three problems in the GHNI, one of those is going to be solved next. and more or less all of them have equal chances.
Right. And like we also have Jay with us. Hi Jay, would you like to introduce yourself with the people lens?
Hi, Aryan. Pujit here. I did Sorry, I lost the context. What are we discussing right now?
Jay, I think some background noise is there.
Yeah, I'm sorry. Network not. Hello. Can you hear me
Hello,
now?
hi Jay. Yes,
Hi,
we can
Jay.
hear you, Jay.
Hello.
Hello, like Jay, would you like to introduce yourself once?
Yeah, so I'm Jay Sharma. I'm from IIT Dhanbad, and right now I'm working as a software engineer at Google. And yeah, I'm one of the problem setters for this contest.
Yeah, which problem is yours, Jay?
I think it's E Parker rectangle. It has
Okay,
been solved by one team yet.
right. Yes. This is a very nice problem. I really like this problem.
It's just a random problem that came to my mind. I was just trying to play with some random matrices here and there,
Yeah.
and yeah,
So,
just
so
created this.
Aryan, maybe it's time we have we discussed any of the problem statements? Maybe we can start discussing if you don't have anything else in mind.
No, like we can start discussing the problems. Like we haven't really discussed anything yet. But
Yeah.
probably I will go there and share my screen once so that I can. Okay, so like which problem, Jatin, would you like to start first?
Yeah. Let's start with the most solved problem.
Okay, sitting students.
Yeah. I haven't really read it, so if anyone has read it,
Okay,
maybe.
like this is mostly based on sitting arrangement in the train, like which we see. For example, reserving consecutive and adjacent seat for a couple on the train can be challenging. The problem asks you to help a couple identify whether the seat numbers they reserved are together or not. Trains typically consist of multiple similar coaches bogies, each comprising of multiple rows. Each row contains two groups of continuous or together seats with a gap between the two groups to allow passengers to walk through the coach. The first group contains two seats and the second group
Aryan,
contains
sorry
the
to
third seat.
interrupt you, but are you on a different screen? You are
Like,
sharing only the dashboard right now.
oh sorry, like I opened it in new tab over there. Yeah, I think this should be
Yeah.
visible there. Yeah, sitting seated, reserving consecutive or adjacent seat for a couple on the train can be challenging. These problems ask you to help a couple identify whether their seat numbers they reserved are together or not. Trains typically consist of similar coaches or bogies, each comprising multiple rows. Each row contains two groups of continuous together seats, with a gap between the two groups to allow passenger to walk through the coach. The first group contains two seats and the second group contains three seats. Let's say the train has n coaches, each coach with r rows. Then the seats in the train are numbered consecutively, as illustrated with the example below. Here is a configuration with n equal to 2 and r equal to 3. So like the first coach has the seats 1, 2, 3, 4, 5 together, 6, 7, 8, 9, 10 together, 11, 12, 13, 14, 15 together. And the second coach has 16, 17, 18 together, 18, 19, 20, and 21, 22, and similar, like you can see the diagram here. Here the dots denotes the space between the two groups to allow passengers to walk through the coach. We can see that there are 5 into n into r seats, and that the seat number will go from 1 to 5 into n into r. The seats are numbered in order from the first to last coach, and for each coach from the first to last row. We say two seats are together if they share an armrest between them. For example, seat 1 and 2 are together, seat 3 and 4 are together, and seat 4 and 5 are together as well. However, seat 2 and 3 are not together, seat 3 and 5 are not together, and seat 1 and 10 are not together, and seat 11 and 10 and 11 are not together. Lloyd and you are a couple and you have allocated two seats numbered S1 and S2 where S1 is not equal to S2. Are these two seats together or not? The input format is like we have T the number of test cases and then we have four spaces containing SR, S1 and S2. And like for each case we should output a single integer yes or no and note that the output is case sensitive and we need exactly yes or no. So like any ideas on this one, like how do we proceed with solving? Like this was the first problem. And I think we can give chat a 5 minute before we start discussing like how probably what would be the expected solution for this one. And yeah. So like I think that probably the idea of like anyone would like to share the idea like how probably can we solve this problem before we move on to the next problem and take a peek at leaderboard again. Okay, probably I would say like the idea is to probably look at the numbers modulo 5. And once we look at there, 1 and 2 would be consecutive, 3 and 4 would be consecutive, and 4 and 0 would be consecutive. And pretty much that would be the idea for this problem. And like you will take a sneak peek at the scoreboard again. Okay, looks like NIT Calicut is trying the first problem basic vocabulary here. And they have a WA on it, and probably we can take a look at like what is the reason for that WA later. So like this problem was a takeover problem based on some real life incident where we tried to look out for a story here.
Yeah, I pretty much like the story of this problem. It's very interesting.
Like essentially that was the idea. Okay, I think we can probably move on to the next problem, Bob to the top.
Yeah.
Sarpe and Ryan are aspiring Broadway actors. Both will do anything it takes to climb the ladder of success. For example, consider this ladder right here. Here, actually, it's more like a staircase. The ladder consists of n steps arranged in a row, whose heights are h1, h2 up to hn, from left to right. To them, a ladder is fabulosa if the height of each boundary step is average of the height of the steps to its left and right. Formally, hi is equal to hi minus 1 plus hi plus 1 by 2. Should hold for every I such that 1 is less than I is less than m. In order to make this ladder fabulosa, they have two kinds of operation. Jump and hoop, choose two consecutive steps and make each of them plus 1 unit higher. Bob, pop, bob, choose three consecutive ladders, make each of them plus 1 higher. Is it possible to make this ladder fabulosa using only these two operations? Note that minimum height step doesn't have to be on leftmost one. And then we have some examples as well. Like if you can see, like example output says yes for all of the test cases. Like for example, for 666 everything is equal right now. 6912 is correct right now. 1296 is also correct right now. 2, 3, 5, 7, 11, 13. Like here we can probably add 1 to 2 and 3. So the number will become 3, 4, 5. Then probably I'm not sure, but we can take a look at example here. Yeah. So it says like this is the way to make the numbers equal over here. And similarly, when we have 2, 3, 5, 7, 11, 13, 17, 19. And like this was one reason why a lot of teams got W on it. Like a lot of just took T as input and tried to print T as 3 times. And like that was it. Like probably any ideas, anyone, like how do we solve this one?
Can we go through the samples for this one?
And like samples, yeah, like samples, like there is only one really good example, which is 2, 3, 5, 11, 13, 2, 3, 5, 7, 11, 13. Here, if you look at like the final array becomes 6, 8, 10, 12, 14, 16. So like the one way to look at is like this is literally the definition of an arithmetic progression. So all the numbers at the end should have an form an arithmetic progression there.
Yeah, that's a nice observation. I think a lot of teams should be able to solve this, hopefully.
Yeah, I think most of them already have. So there are 72 teams, and out of them, how many have solved it?
Like
52.
Like last I checked, 55, 50, 52 have solved. Okay.
Okay, nice.
so, like any ideas above on this one? Like the observation we have is like it's an arithmetic progression over there. So like what will you do after it? you see this observation?
I'm just thinking that whatever the difference is between the first two elements, if we um, just keep that as as the arithmetic difference for for the AP, then um, I think we can try to sort of simulate it. But yeah, I think like we might be able to find some condition where um, you know, given some fixed difference, there is some failure condition. But apart from that, I think for everything else we would get a yes. But
Right?
I think you'll have to do some.
The solution will actually work. I think it will work. I mean, you don't have to do all this. There's a very like,
Yeah.
yeah, I will not spoil, but yeah. But
Mm.
I think this will actually work.
Yeah, I mean, we need not like actually simulate it, but I think by
Yeah.
just simulating one or two cases on paper, we can find that condition to um,
Yes.
get some failure condition basically.
Yes, but that's. I mean, yeah, you cannot say for sure that is enough. For example, suppose because your assumption is that if there is a solution, there will be a solution with the difference equal to the difference of the first two elements, right? But that assumption is not like
Yeah,
why is that?
that's not
Uh,
exactly true.
if that
Um,
assumption is true, then you can probably simulate and then you can find the condition also.
mm. Yeah, right. But maybe what we can say is that if that is the minimum difference, so let's say that difference is D, then
Yeah,
maybe if we can say that if like for any distance greater than equal to D,
yeah,
we can find some condition because I guess that's the lower bound, and then you keep incrementing the second
yes.
element until you find some valid D and
Yeah. This is actually a good intuition, but yeah. So yeah, more or less the solution is along these lines.
mm,
So essentially, the way that you got a lower bound, you can also get an upper bound, right? If you consider the last
mm.
two elements,
Yes, that makes sense. Yeah, because
and
we
then
already know the number of elements, so
yeah,
um,
no. So the lower bound essentially is from the fact that the difference between the first two elements cannot decrease, right? Like the A2
right,
minus A1 cannot decrease.
right.
Like similarly, you can show that the difference of the last two elements cannot decrease, right?
Yes, that makes sense.
Yeah. So essentially, you have a lower bound and an upper bound, and it turns out that if that lower bound is less than equal to that upper bound, then there's always a solution.
I see. That
And
makes sense.
in fact, you can choose the difference to be anything between that lower bound and that upper bound.
And upper bound. Oh, that's very interesting.
I think so. I think you can do that.
Mm.
Yeah.
And so we know the lower bound. I'm just so the upper bound will just be the difference of the last two numbers, or
Yeah.
And like the way I see this problem is like we can basically increase any range of number as long as selected numbers are at least two.
Yes. Yes.
So
mm,
like if we look at the consecutive differences of the number, like all the differences can be increased to like whatever value we want, right?
mm, I see.
Uh, yeah. I mean, with the like the small caveat that you cannot like
Uh,
so yeah you cannot have
Like we
uh,
cannot increase the first difference. No,
yeah
wait, we can increase it, but we won't be able to decrease it because we do
yeah
not have a number before one. And
yeah
similarly, we do not have a number after n, so we won't be able to do that as well.
yes but yeah I mean that isn't enough, that does not prove that you will always have a solution. I think the proof is not that not that straightforward.
and like we have few more aces on the scoreboard. Like light low has solved like Parker rectangle, and BUET nightfall has solved basic vocabulary, and SUST gas forces has solved the Parker rectangle one.
And we are 2 hours into the contest,
Like we have 3 more hours.
more or less. Yeah.
Before we jump on to the next problem, maybe I'd like to hear from Jatin about his recent Iowa experience. Like, I guess you have been coaching the IOI team, helping set IOITC and so on. So,
Yes,
what
yes.
has that experience been like?
Yeah, so that has been amazing. And especially also for those who don't know, I was the deputy leader last year for the Indian team, and we went to Hungary. And so it was our best performance yet, and we had won gold after I think like 9 years or something, and yeah, it was amazing to be a part of the team, and it was really fun, a lot of fun. Yeah.
And like, how was the Hungary, the place itself there? Like,
Yeah, it was nice. I don't think like we got to like so the place where this event was held was not like the main city of Budapest. It was in a smaller city, and that was also good. Like Hungary has a very rich culture, uh, and like a lot of nice places to roam around. Yeah, so that was also really nice.
like you probably would have got to meet a lot of people, a lot of teams there, right? And a lot of the
Yes,
deputy leaders.
yes. So yeah, so a lot of so I did meet a lot of people whom I had only seen say on podcasts or something.
That's
Okay.
pretty cool.
And like, did you look at the problems of the contestants? Any feedback on them as well? Like, are they
The
easy compared to pro
problems
forces round or really
No,
hard
they are
compared
actually
to them?
harder. They're actually harder. So they're usually the full solution for II problems is like Div 1, I think Div 1D and Div 1D or Div 1E at least in a Div 1 only contest. And yeah, so because there are 3 problems and 5 hours, so I love the II format more than this thing because it gives you more time uh, to think, right? It gives you enough time to, so it gives you 5 hours for 3 problems. And personally, I think I am better at solving hard problems given time than solving easy problems fast. So I really like the format. And again, subtasks are also really nice. And usually the solutions are such that, when you start solving the smaller subtasks, you get intuition for the bigger subtasks. And that is also really nice.
So in a way, like the problems act as a hint for the full solution there, right?
Yes, I mean not always, but yeah, it is often fruitful to think about the smaller subtasks. For example, if the problem is on trees, then there is always a subtask that is on paths, right? So you get some intuition from the path version of the problem, and then you try to generalize your solution to trees. Right? Maybe you form some hypothesis, and then you figure out whether it works for general trees as well, not just for paths. So,
Got it.
So, so I think one of the participants, one of the members of the Indian team is a member of IIT Kharagpur. I think a
Yes,
team from IIT Kharagpur. And
yes, right. Their
yeah,
team name is Dumble, something like that. And like
Gundam of right.
they in fact won the Amritapuri regional, if I remember correctly.
I see. Nice,
So like
nice. Yeah,
they have
Shyam.
in fact qualified. I don't know why I don't see Kharagpur. Maybe they decided to skip the contest today.
I see. Yeah, that's nice. So
Yes, looks like they have skipped the contest today. Yeah.
yeah, I think there's a question in the chat which asks that so they say that they understand the difference between the first two will not decrease, but can you explain how this holds for the last two? So for the last two elements, right? Either either only the second last is like increased, in which case the difference between the last and the second last decreases, right? Or both of them are increased. Both the last and the second last are increased, and in that case the difference remains the same. So it can never happen that only the last element is increased and the second last element is not increased, right? Hence the difference between the last element, so an minus one, that never increases. It always decreases. So the original difference will always be an upper bound on the final difference.
One other thing that we have discussed during some of the previous regionals is around organizing more camps for students, because earlier I think there used to be some special camps. Um, so I wonder if we should do more like online camps or something like that, so that it's accessible to more people. Um, it could be like based on some criteria, like we could hold a mock contest or something, but
Yeah.
maybe like helping coach some of the bright young kids, not just for IOI but also ICPC, I think
Yes.
might be useful.
Yeah. It should be definitely.
One thing I've observed is that at least in other several other countries, their software companies sponsor local contests a lot. So I think we should also try to um, catch up a little bit, because I'm pretty sure that local companies want to hire a lot of good talent, and this would be a great place for them to do that. So yeah, maybe we can try to have some sponsors for camps and so on. I think
Yeah,
all of
that
that
should be.
would be, yeah.
Yeah, that should be amazing if we can uh get get that somehow.
Yeah, I guess hopefully
Yeah.
Balaji is listening to the live stream. So
Yeah. I think
um,
more importantly, we so what I have observed is that so I'll tell you my IOI experience and IOI training camp experience, and so I believe that the outreach, like the awareness is like extremely little amongst the school
mm,
students.
right.
And I have observed that like the most of the competitors, most of the programmers who get extremely good at like LGM level good at computer programming, they start very early.
Mm,
So most of us we start like in the first year or second year, I think, of
mm,
our colleges. I'm not speaking for everyone, but say I certainly did, right?
mm.
So and it gives you for very little time to actually
Yeah,
get there so fast.
yeah, that's true. And I
And
guess
and I noticed that like for example, every participant in the camp for most of the years I've been there is from a big city, and I think a like huge amount of Indian talent is in small towns. And there is no awareness in small towns about this.
Like the
Anyway, I
way,
think we are digressing. Yeah, digressing a
but
bit,
yeah,
but
the way I see it over here is like generally when someone knows like someone went to IOI or IOI training camp nearby, then someone else looks at them and starts preparing over there. So like for example, if you look at like most of these are probably some elite school or somewhere who have a senior who have already been to IOI training camp or who
yeah,
tried to go to IOI. while
Even more than that, most of the participants I think are coming from the IMO side. So I talked to a lot of participants, and a lot of them were like, a friend of mine suggested that I also participate in IOI training camp when I went to the IMO training camp, right? And then I started with this.
yeah, like this time there was a huge overlap between IOI training camp and IMO training camp as well. Like a lot of people were in both the camps. So yeah, that was
Okay, I feel that the onus is more or less on us to, you know, propagate these things to smaller towns. Just like I think at some point cricket was not that popular in India, right? But then people sort of organized more grassroots level awareness programs. Uh, I feel it's kind of like that. It might take some years, but we have to start somewhere and might as well do it sooner rather than later.
Yeah.
like what I say is like a lot of teams are trying to solve this problem only. And at least I don't see someone attempted the last problem.
Yeah.
Like I would probably look at this team, Malana team. Like I remember in the online round, they were the first team to solve the hardest problem of that contest, and one of the two teams to get it. Similarly, in the two regionals they participated, like they were trying a different problem, jumping out of the queue, and they were successful in one of the contests, while the strategy failed in the other contest. So it would be interesting to see like if their strategy works in this contest or not. And probably, Jatin, like, would you like to share the screen? Like, I can fetch their submission over there, and we can take a look at it whether how close they are to getting an AC on this.
So okay, yeah. So should I? So what should I do? I should discuss the next problem, or
Yeah, we can start discussing the next one. Like,
yeah. So I hope that you can see my screen.
yes, we can see your screen.
Yeah. So okay. So I won't go into the whole like statement. I'll just discuss you know the crux of the problem statement. So the problem we are discussing is so which one is lesser solved? Uh,
Okay,
like
which
maybe
problem to pick
yeah.
it up?
Yeah, so
So,
like
like,
which problem is more so Parker rectangle is more solved. So let me just discuss that.
sure.
Yeah. So here we are we are given an integer n, right? And we have to create a matrix, right, where the sum of the number of rows and number of columns is n, right? So we have to create a matrix with R rows and C columns. R and C you can choose any way you want to be, such that their sum is equal to n. That is a constraint, right? And you have to choose it in such a way. So for example, the question that C has so are the sums of rows, like the sums to x sums of rows. And so really, so y1 to y3 are sums of columns. And in the set, so the arrow difference. So if you consider all these in the set as well, the difference of 22 cannot see one bit. So you want for s is equal to 1 consider of these six sums. The difference between the natural difference must be less equal to 12, right? If you try to test from there. That's okay. So you have to first to calculate whether it exists, and you have to bring it. And you have which are all with right? So there are n square and so having the so all the CMs should be listed. So these people are extra, do not various sums, right? And that intuitive sums is like C number. That's what it's right? So and yes, so J and now I above in areas. So problem set is the problem here.
Yes, the problem states here.
So
And
just
probably
remind
like,
n is given to us and R and C we choose anyway you want. We can choose R equal to 1 equal to minus 1 if you want. We choose R equal to 5 is equal to minus 5. Anything we want.
Okay. Now, like, probably, like, we can
also
people add, sir.
Yeah, maybe
Yeah,
also
probably
give
example
example.
would be there.
Yes. Right. So in fact, I'll give an example. Okay, so let's consider this example. So suppose n equal to say 6, then suppose I choose R and C what to be 3. So I'll show you the matrix. So in fact, for this example, I'll show you a matrix and the sums are all the same, right? So
Yeah, like 3 cross 3 on every row, per diagonal, same. Like,
no, not that.
is the puzzle is the puzzle we used to solve when we were small. Like,
Oh,
we don't really need for the matrix, but yeah.
3. Oh,
I remember like trying to find the 3 cross 3 matrix
so
or closed diagonals.
but all the elements are also same, right? As you
Like,
can
in
see.
fact, there you may consider that all the numbers will be between 1 to 9.
Right. So here, suppose you consider this matrix, right? And then also, I forgot to mention that the elements have to be unique, right? So you see in this example, all the elements are greater than equal to 0. And the tree, of course. So to get this example, you'll find that every row and every column sum equal to 12, exactly equal to 12. Like here, 7 plus 5, 2 plus 6, 8 plus 6 plus 1. And similarly, if you look at the columns also, the sum is exactly equal to 12. So in this example, in fact, there is no difference between any two sums, right? But maybe there could have been an example where they find this error was swap, right? So if you look,
So you can see the sample test case as an example where the difference is not the same.
yeah, I think with this very small change, I can actually.
Yeah.
But no, so I'll show this example which is actually incorrect. So here, if you consider this matrix, you just swap these two, right? Thing changes some of these two columns. Now this becomes 10 and this becomes 14. And this is not a value, so because 14 minus 10 equal to 4, which is greater than 6 by 2. So this is an incorrect solution, right?
So you swap 2 and 3, you get a right solution instead of 5 and 7.
Yeah, so if you had swapped 2 and 3, you would have got it, because the delta would have been 2 instead of 4. So
Like, Jay, you are the problem set, like
yeah,
any like idea like how did you come for this problem in space way or like
So I will mention that we used to solve such kind of problems when we were in maths. So I was interested in such kind of problems which have some cool properties of matrices. Yeah. So I know what magic squares. These are such matrices that some of all those and there are like algorithms in magic square. But, like simplest algorithms exist only for like a odd order matrices, like plus 3, 5, plus 5, and all. I tried to come up with a easier like algorithm to build it for even order matrix. I wasn't able to come up with the exact equal kind of matrix, but a matrix where the sum were close enough, the sum of all rows and columns close enough. And it's and once you get the solution, you will see that it's very simple solution, and there's not much
actually,
improvement.
one which I was wondering about is whether it is always also possible for even n to have all the sums the same.
For even sums to be same.
Yeah, so that there exists square matrices where so right now they're running by n this number
You
of
can basically, right?
sorry?
You can NI to your ring and
Right. Yeah. So one issue is that the number of rows and columns are actually very similar to each other. Otherwise, the rows and the average of the columns would be very far apart, right? And that
Yes.
actually is true. That is true. Except for very small cases, yeah. You can prove that with like with some basic that you must have the number of rows and columns to be the same. And it's I mean like greater than equal to 6 or 7 or something. Yeah. So and for I won't give you the exception. I will think about it. For there always exists a solution which all systems are the same. All the two like so n total n is like this is like 2 into by 2. So n is equal to 2 into k where k is open. So all k rows and columns right, have the same sum. Right? There exists medicine. I did show you such a matrix for 3 to 3. Right? All the sums are 12.
Yeah.
So my question is, does this also hold for 1? Can you, so the question is not asked. So what the question had instead of n by 2, but we had 0, for example.
Sorry, 0.
So so the question is, if I had this, what if I had this?
Okay.
All the
So
sums.
the matrices do exist, but they're not simple to perfect them.
Basic.
You have to go through some basic algorithms and then you have to do some shading here and there. And it's pretty much a mess to implement.
I think I'm going to looking for n multiples of 8. If n multiple I think is
That is simple enough, but if n is a multiple of 4 but not an 8, multiple of 8, then it's a messy monster.
I see. Very nice.
So I relax constraints a little bit to let it be up to C line, but not almost resolve it. Like it's pretty simple to implement also. Very simple to do.
So
Start with that. Start matrix where field on number from 1 to a square row y. And try to miss that.
I actually have That's a lot for and to you guys person.
Yeah, nice to have you on scene.
Bye guys. Bye.
Yeah, Jatin.
Thanks, Jatin.
So anyone's to reply or should I give up the session?
And like now, like if I have to try, like one thing we have discussed is like number of rows and columns are almost equal. And
Yeah, should be almost equal.
like the way I see it, like, for example, if n is 11, then we can pick now rows as 6 and columns as 5.
Yeah, but actually there's a proof that for large enough n, let's say for n equals to 13, 15, 17, even like close enough network, you need to have it exactly equal. So for bigger values of n, answer doesn't exist.
Okay.
Because
And
like the average of like 5 rows and 6 columns, it's difficult to make them same when n is larger.
got it. Like, and it comes up from the fact that numbers should be distinct, right?
Yeah, the number should be distinct. And you obviously want them as close enough as possible. Because
Oh,
there's no point in like taking numbers like 1 and 10 power 8 and then 10 power 9. It makes no sense for that.
okay. This one looks interesting. And like the one idea I have right now is I think we'll have a difference of n or something like that. It's more like placing 1, 2, 3, 4 up to r in the first row, and
Yes.
then 2r, 2r minus 1, 2r minus 3 up to r plus 1 in the second row, and then mirroring the same parts. But wait,
When
in
you
this
just say
case, the problem is like the columns will have same sum, but on rows the sum will increase by n, right? Each row, here the sum is increasing by
yeah,
n.
but actually the columns and rows will have quite different sum. The sum of a row will be much larger than the sum of a column.
Like one thing is for sure that I will probably add numbers only in range from 1 comma r 1 to r comma c only.
Yeah.
Okay, like we at least have a team which has solved 4 problems right now. Lightlow from BITS Pilani campus is at top. Like they managed to solve this Parker rectangle basic vocabulary on the problem sheet. So, like probably
We also have Malana team trying to solve VTS to watermelon.
like I did in fact look their submission and like they are using FFT over there, but that's not the intended solution. Although like the crux of this problem is like n is up to 2000 only, and like there is a variable mod over there. So like the expected solution is n square. Had n be an FFT friendly mod over there, then it is in fact possible to solve this problem in n log square. And this is really compared to what the intended solution is. Probably like in the early context, ICPC double not such a function. And like so in this way, I will probably try to solve problems once. The other way I'm thinking of is like earlier I was making all of your numbers equal, right? 1 to r in the first row, r plus 1 to r in the second row, 2r plus 1 to 3r in the third row, right? So I can reverse the order, like 1 to r in the first row, and n minus 1 r. Okay, like shuffling. Yeah, right now let's shuffle. Like initially my order was like the
It
way I
will
will
be
do is like
nice if you can like show how you are trying to build the rectangles.
okay, like give me a minute. In fact, I can fetch a whiteboard here.
Yeah.
Mhm.
Maybe you should use a spreadsheet. It will using that you can
Like,
automatically find.
I have a dedicated whiteboard with me. I'm just
Yeah, I'm
starting.
just saying it will be easier to find the sum of rows and column if you use a spreadsheet.
Yeah, that's an interesting idea. So like, let's pick n equal to 12 right now, or probably I can pick more. The first day was like attacking numbers like this. It may be like isolating a smaller example, but anyways,
Yeah, let's start with the four matrix. That'd be easy.
like 4 plus 4. the very first idea I have to number this. Like your colors are same, but those are very different. And like that will be the first idea. And the next idea I would like to shift these roles like this. Like first was the largest sum, small and the largest, the second one was second largest sum. Like this is not change the rules, but like once we had like what I do then fix numbers here. For example, if I be here, then you see like the first rules have these over here and the values. And this will not make a difference exactly the number of rows here. And I think that's what we are looking. So basically switching numbers is to give you the order. But if you can see like the sum is exactly in. This is how I would probably come with the answer. I realize it. First, what to understand, as and numbers so smallest C numbers would be in the first one, largest C numbers would be in the second row. Then this among the remaining part, I can keep doing the same thing. And like once I am done with this, I can grab two numbers in every row over there, and like that would be my solution over here. And I think I can generalize it more.
Yeah, that's exactly a solution. I would like to put it forward in a better way. You start by writing the numbers from 1 to n square sequentially, row-wise, first week. So you start with 1, 2, 3, 4, 5, 6, and 8, so on. Then you reverse the second, fourth, sixth, eighth, so on rows, and finally you reverse the second, fourth, sixth, eighth rows.
Oh, right, that's interesting part. And
Yeah,
right, and essentially, if you look at it, that's what I
it's
ended
the
up
same
with.
as a solution. Just it's a bit easier to visualize it that way.
Mm,
So that's
So,
the solution for like n cross n where n is even. When is odd, they're just magic squares.
and in your solution, how are you picking which elements to solve currently?
Like the way I am picking over here is like first you are like I created the original matrix
Yeah,
for the swap party.
right.
Okay, then like my idea simply to pick on I equal to 2 and I equal to 2 and like j 1 2 j plus equal to 2 and I'm swapping I comma j with comma j plus 1. So basically like the numbers first, then these numbers, then these numbers and these numbers.
Yeah, makes sense. Cool.
So that was the which I came up over here and a lot of things are coming up over here. Like I think the hard part was problem is to prove that after a certain
See that for small order, it's still possible. Like n equals to 3, n equals to 5, it is still possible. That's probably what something solves.
okay, we are now more teams with forces. Like light low skill issue has also solved for problems. Like it would be interesting to see like which problem gets picked up next. Because until 4 problems scoreboard gives us then the hint that these problems are solvable. Like, I would be interested in knowing like, what these teams try to pick next. And, like the way like my recommended to get watermelon next. And then probably like skill issue or cabin in the wood like will be 50-50. Like you can pick one and try to go all out on those problems. For this 5 and mod inverse level, I don't have to get solved in the ones. That is what we need. And we have one team that's trying the last one, but I'm not really sure how close they are. Like at least by that, at least Malala is trying to get really it produces right answers.
Right, right. They have two TLEs so far, right?
Right.
Okay, let me just try running their solution quickly. It looks like it's incorrect. Also, yeah, I'll have to see what's wrong with the solution. But currently, at least on my machine, the solution takes around 13 seconds, 13 to 14 seconds.
And is in fact also doing wrong, so right?
Yeah, wrong answer.
And like, can you try checking the answers, like where the mod is less than 1? Like, although that's an value, but you can probably run your solution on some test cases with those as a mod, and their solution as that as a mod.
Okay.
Basically, I like one thing I've checked myself for the mod team is like W is due to like not double labeling or this is like double.
I mean, I'll check, but looks like their reference doesn't have a lot of terms that we should have. But yeah, let me try to generate some test with a small. Would you like to pick a mod?
I have to like let's like 1003 is fine. 1003 is not him. 1007 have to be. 1007 is also not fine. 1009, let's see the 9
1009.
and like take any 9.
Let me results from my sessions. Okay. For this, there are solutions do match. Yes, now I see that they do have the required terms in the records. Earlier, I thought I wasn't seeing the code properly, I think. Okay, so yeah, I think it's due to the mod, probably.
I didn't be in effective friendly mode in the beginning. So
yeah, but hopefully they'll be able to realize that they don't need FFT.
and like the other reason to have a variable mod here is like you do not want people to double tensors or like that. Because you see like the only variable which is 1 to 2,000.
Yeah.
And probably like this like stream is probably lagging. So whatever we do there, I don't think people would have.
Guys, I have to leave right now. I'll join you after 1 hour, just before the scoreboard freezes.
Yeah, okay.
Bye.
Bye. Thanks a lot for joining.
Thanks a lot. Okay.
I see like I see that the stream is just stuck over there.
Okay.
At least last 20 minutes or so, no progress.
Okay. I think contests are not making progress. We can complete now.
So
you.